How does air property change affect psychrometric variables? Imagine walking into a room and feeling the air's temperature and humidity shift. These changes tell us a lot about how the air behaves and how we can control it. When air properties change, they directly influence the psychrometric variables that describe the state of moist air. These variables include dry bulb temperature, wet bulb temperature, relative humidity, humidity ratio, dew point temperature, and enthalpy. Understanding these shifts is key for designing and running effective heating, ventilation, and air conditioning systems. Let's start with temperature. When the dry bulb temperature, which is just the air's actual temperature, goes up, the air can hold more water vapor. This means the relative humidity, or how much moisture the air holds compared to its maximum capacity at that temperature, drops if the moisture content stays the same. For example, raising the temperature by 10 degrees Fahrenheit can lower the relative humidity by about 20%. Conversely, cooling the air reduces its capacity to hold moisture, which increases relative humidity and can lead to condensation if the dew point is reached. Humidity changes also play a big role. Adding moisture to the air, known as humidification, increases the humidity ratio and makes the air feel more moist. This can impact comfort and the energy needed to condition the air. Removing moisture or dehumidification lowers the humidity ratio and relative humidity, which is often necessary in humid climates or to prevent mold growth indoors. Pressure is another factor that influences psychrometric variables. At higher altitudes where atmospheric pressure is lower, air density decreases, and the psychrometric properties shift. Most charts assume sea level pressure, so adjustments are needed for accurate calculations at different elevations. Enthalpy, which measures the total heat content of the air and water vapor mixture, also changes with temperature and moisture content. When air is heated or humidified, the enthalpy increases, meaning more energy is stored in the air. HVAC systems aim to control both sensible heat, which affects temperature, and latent heat, which involves moisture content. In practical terms, engineers use psychrometric charts or software to visualize these changes. They start with the initial outdoor air conditions and then plot the desired indoor conditions. The path between these points shows what processes are needed, whether cooling, heating, humidifying, or dehumidifying. Changes in air properties impact the loads on HVAC systems. Sensible load refers to the energy needed to change the air's temperature, while latent load involves moisture removal or addition. By understanding how air property changes affect psychrometric variables, engineers can design systems that keep indoor air comfortable, control humidity levels, and operate efficiently. In summary, when air temperature, moisture content, or pressure change, they shift the psychrometric variables. These shifts influence how much heating, cooling, humidifying, or dehumidifying is required. Knowing these relationships helps HVAC professionals create systems that maintain comfort and save energy. Psychrometric analysis is a fundamental tool for predicting and managing air behavior in any building or system.